let's look at what happens if we raise I to some positive powers. And normally we would use radians for the angle on an argand diagram, but I'm using degrees today just to illustrate this introduction. So I to the power 1 is simply I. So if we put that on the argand diagram, we can see that I is going to be here, and the angle measured anti-clockwise from the real axis is 90 degrees. Now let's square I. Well, we know that I squared is -1. So on the argand diagram, -1 is over here on the real axis, and we can see the angle, once again measured anti-clockwise from the real axis, is 180 degrees. Note that 180 is 90 times 2, and remember 2 is the same as the power we've raised I to. Now we do I cubed. So I cubed is -I, so that brings us down to -I on the imaginary axis here. The angle is now 270 degrees, and we just cubed I. Notice that 270 is 90 multiplied by 3. If we do I to the power 4, that brings us to 1. And 1 is just over to the right on the real axis. Now obviously the angle here is 0, but we could also think of it as 360 degrees. And 360 is equal to 90, the angle we had for our original number I, multiplied by 4. Remember, we raised I to the power 4 in this final example. So in other words, every time we raise I to a power, we end up multiplying the angle by that power. And the I vector, or the unit vector, I should say, simply rotates around the origin in an anti-clockwise direction.